Okei, hyvää iltapäivää. Good afternoon, everybody. Today we will take a new concept concerning centroid of the plane figure. I'm not going to draw anything with my hand, and I am only using a ready PDF file which you can find from the material from the Moodle, but I will show that to you. I think now you will see this PDF here. Centroid of the plane figure. It means the center point or midpoint of the figure, whatever. Well, actually, this example which we are concerning now is only a figure which is somehow rectangular, or figure which can be shared to the subregions which are rectangles. And this my example here is that I will zoom it a little bit. I have drawn that picture there in a coordinate system where the x-axis goes to the right hand side and or right from this origin, and the y-axis goes downwards. You don't necessarily need to do like this, but I use this method because this is quite usual. For example, in mechanics of materials, many times we use a coordinate system where the y-axis goes downwards. There are some reasons for that, but it doesn't matter. Of course, you could calculate this also by using more conventional method where the y-axis goes upwards. But the calculated method is the same, whatever your coordinate system is. And now we have this kind of figure there, and I'm trying to find out where is the middle point of this figure. It is always very easy to find center point if you have simple figure, for example, circle. The midpoint of the circle, you can guess where that is. And also rectangle is very easy to see where is the center point. But this kind of figure, it is not so easy to see because there are many subregions there which make it a little bit harder. But let's see how we can solve this problem. This middle point or the centroid point of the figure, it is quite usual problem in many cases. For example, I mostly work with students which study civil engineering or building technology, and they, for example, these figures which I have as an example, they could be, for example, some kind of concrete elements, and when you are in the building site, you want to raise that element in a horizontal position so that it doesn't winkle. Then you need to know where is the center point at that element. Then you have to coordinate that racing so that the what is this, cable or string or whatever. No, it's not string. I don't know the word in English, but so that it goes through the center point of that, for example, that concrete element. And now I have used this kind of method. I have divided that area to 3 sub-areas. It can be made with many ways. This is one possibility. I have used vertical lines. Here you can see, so that I have divided it to the original figure to the 3 sub-regions or sub-areas, and I have colored them with different colors that it is easier to see what are those sub-parts or sub-areas there. Of course, that coloring is not necessary, but it is probably easier to see where those sub-parts there are. And also I have drawn there a small circle in the middle of every rectangle there. So with this method we need to find out where is the center point of every rectangle which we have there. Now we have 3 rectangles, and we need to find out where are those midpoints or center points of those rectangles. And also we need to know what are the areas of these sub parts there. And now I have started to calculate it, and first I am taking 5 or maybe 4 or 5 things I have to find out from every sub area. Breadth and height, or this breadth can also be called width. I use this English word because the most common shortened or the letter which we mostly use when we want to use one letter for the measure of breadth or width of some figure, that is most commonly or most usually B letter, and it comes from this word breadth. That, or at least I guess that's why. In Finnish, breadth is leveys, and height is the height, and there we use mostly this letter H. And then we need area, or again this uppercase A comes from area word. And then we need the coordinates of the center point. And I'm now trying to explain what I am doing here. First I find out the breadth of the first area. Usually we could measure that. We would take some kind of ruler or whatever which we can use with the measuring of the length of this horizontal measure, or the breadth or width of that figure. So this first sub part there, we can see from the coordinate axis that it ends at the point 1.9 in the x-axis. So the breadth is 1.9 meters. And also the height can be seen from this vertical axis or y-axis. Here is 1, and here would be 1.5, and so this would be 1.4 meters. So area is easy to calculate because it is a rectangle. We just multiply those measures with each other, and we get the area there, 2.66 square meters. And then coordinates of the center point. Mostly this first rectangle there is usually the easiest one, and almost never we make mistakes there. But these other two are a little bit harder, or you have to be much more careful there for not to make errors there. why is it simple in this first rectangle? It is because it touches both axes here. It touches x-axis and also y-axis, or it is located in the origin, or one corner of that rectangle is at the origin in the coordinate system. So that's why the center point is very easy to find out, because the breadth of this figure was 1.9 and the midpoint must be in the middle of that, so it is 1.9 divided by 2. So this gives us the x-coordinate of this center point. And the same holds with y-coordinate, because the height of this figure is 1.4, and if we divide that by 2 we get 0.7. So these are the first 5 values we need to find out the center point of the whole figure. This is the sub-area 1. And then sub-area 2, which I have colored with some kind of blue color, the same thing. The breadth or the width of the figure we can calculate from the count here. There are grids in the figure, so there will be 1, 2, 3, 4, 5, 6, and one grid is 0.1 meters. So the breadth of this figure will be 0.6 meters, as we are seeing here. The subscripts there are denoted with number of the sub area. So in the first area we have only number ones there, and then here we use 2 as a subscript. There are some noises around my studio. This is not my studio, but I'm borrowing this for a while. They many times make some kind of interviews there behind the wall in the back of myself, and sometimes, and I don't know if you hear any noises there, but I hope not. And the height of the figure also, it is quite easy to see. This 0.8 here would be 1 meter in that line here, and 0.2 away from 1 it is 0.8. These are very simple ones when you watch your own picture, or you can measure from those if you have that original object in your hands. You may make those measurements easily. And then the area is also simple one. Always again multiply these figures. So the area is 0.48 square meters. And now the coordinates of the center point here is the point of mistake many times, because now we have to be careful. The x-coordinate of this figure, it means the distance from this vertical axis. So it is not this length here. You can't get the y-coordinate just by dividing the breadth of the figure by 2, because this figure is not touching the vertical axis there. As you see here, it is not simple dividing by 2, but we have to take first 1.9 meter to find out the place of the or the point in the left hand side of this figure, this blue figure. So this measure the length of this or the horizontal length of this yellow figure is 1.9 meters, and then we add half of the breadth of this blue figure. So we get 1.9 plus 0.3 or 1.9 plus 0.6 divided by 2. So these are very usual places where students and also myself make mistakes in these problems. And then the y coordinate, it is easy in this case, because the blue figure there, or this blue rectangle, is touching the horizontal axis, so it is easy to find the midpoint of the or the coordinate y coordinate of the midpoint just by dividing the height by 2. The height of that figure was 0.8, and when we divide it by 2 we get 0.4. And then the last one, which is, I don't know if that is pink color, probably it is, but I have written there that it would be pink color there. The same holds here. The breadth and the height we can measure there from the figure, and those are quite easy to check that they are 0.6 and 0.3 meters, and area is easy to calculate. And now coordinates of the center point, the x coordinate again is a little bit harder, or a place of error there. To find the x coordinate of this center point of this last figure there, or last rectangle there, we have to first come from this vertical axis horizontally to the border of that third figure there. It is 2.5 meters, or if we add or sum the breadths of these two first figures there, first was 1.9 and the second was 0.6. 1.9 plus 0.6, that equals 2.5, and as we see here coordinate, we are actually in the border of that pink figure there. And then we add the half of the breadth of that third figure, and here we can see what I did. 1.9 plus 0.6, and then half of that half of that breadth of the breadth of that last figure there. This may seem a little bit strange, because now in this case we have this coordinate system here written in the picture, so we actually can see from those coordinates what are those coordinates of the every figure. For example, we don't need to calculate anything, because we can see that, for example, this center point in the third figure there is at the place where x coordinate is 2.8 and the y coordinate it is 0.15, or did we calculate that already? No, I forgot that. It was because the third figure touches the horizontal axis, then the y coordinate can be calculated simply by dividing the height by 2. But also we can see that from figure. But you have to remember that you don't see any coordinates in real life. If you get some kind of for example, this element, concrete element there, you can't use any coordinates there. You only have to do measurements. But in calculation process, you have to use some kind of coordinate system, and for example, in this case, I have drawn that those coordinate axes, so that it touches the origin is at the left hand upper left corner there of that first figure there. So that's why I made these calculations here. For example, this x3 here with this method, because usually if you are in real life, you want to find how far away from that left hand side of that figure is the midpoint of that third part there. Then we could do that by measuring the length of this part and length of this part and half of the length of this last part there. And that calculation process is like this here. Okay, now we have find the important numbers for every sub-areas. We know the area and we know the coordinates of the center point of each figure there. And then we find out the formula for the coordinates of the centroid or middle point or center point of the figure. And here is the formula. It is quite easy to remember this. I'm wondering, it is strange that actually I haven't ever found a formula book which would tell you this formula. At least I don't have any formula books which tells the formula for coordinates of the centroid. I am wondering why not, because this is quite a usual problem, and still this formula you can't find almost anywhere, almost nowhere. But it is easy to remember. If we you can see it can be calculated with the formulas. If you compare this x and y formulas there, they are almost similar, or they are very similar. The only difference there is the number of or name of those coordinates of midpoints. When we are calculating the x coordinate, we use x1, x2, etc. And when we are calculating the y coordinate, we use y1, y2, etc. And what can we see here? In the bottom part of this division, we have the sum of sub-areas. A1 plus A2 plus A3 plus A4, etc. It depends how many subparts you have. For example, in this case, we had only 3 sub-areas there, so this formula would be the formula in the bottom part of this division. There would be only A1 plus A2 plus A3. And what is exactly that sum of the areas of sub-areas or sub-regions there? If we add area of this yellow figure and area of this blue figure and area of this pink figure, we add them together, so that means we get the area of the whole figure, and that is always the number or the area in here and also here. So if you somehow have calculated the area of the whole figure, you don't need to anymore do it again here, because you already know that the sum of these a's in the bottom part of this division is the total area of that figure. And it is the same figure in the bottom part of both coordinates, x and y. By the way, this c subscript there, that comes, you may think that it comes from coordinate, but actually it comes from centroid or center point word. Sometimes, and I usually myself, when I'm not when I don't have to teach in English, I mostly use zeros here, so I would write this x0 and y0. Actually, I don't know why I do that, but maybe it's logical that it is 0, because here you get 1, 2, etc. And maybe it's logical to have x0 in the left hand side of this formula. But xc means the x-coordinate of the centroid or center point of the whole figure. And here we can see we have multiplications, a1 times x1, a1 times x1. So here we multiply the areas with the coordinates of the center point. So area of the part 1 times x coordinate of the part 1. And the same holds here, A2 times x2. And if we have that third one there will be A3 times x3. And the same with y coordinate, but that exception that we don't use x's there, but they are y's. So this is very easy to remember this formula, even though you don't have any formula books where that is told you. So in this example, you can see I am calculating the coordinates of the center point of that figure we had, and here I am using those numbers which I calculated there. There are those areas there from the every 3 subregions there, and there are x coordinates of the center points of each rectangle. And in the bottom part you have the sum of those areas. So actually when I calculate the x coordinate here, it is useful to calculate the area, the value of the total area here, because when I once calculate that, I don't necessarily need to calculate it again when I am calculating the y coordinate, because here you get the same number there, or the same area. So usually when I'm calculating these centroids, then I don't 2 times calculate the same area there. I just simply write there 3.32. Well, not every time 3.32, but in this example I would do so. So here we can see that in the top part of the division there are multiplications where area is multiplied by length, or if we use dimensions or units, square meters are multiplied by meters. As you probably remember, when we are multiplying m squared times m, we have the exponent 1 with this m here, and we can add those exponents. So we have 2 plus 1, that makes 3. So actually the unit of the top part is cubic meters, or meter raised to the power 3. Actually that is not any volume, even though the unit is the same as volume has, but it is not the same thing. There are many concepts in physics or mechanics where we have same units with the total different phenomenon. For example, this cubic meters is one example. Not every time cubic meters means volume, even though it is probably the most common case where we have the unit of meter. Sorry, did I say cubic meter? I meant meter raised to the power 3. Which is the same as cubic meter, probably. Yes, I think so. I so not so often use these units in English, so I many times forget those names in English. In Finnish, by the way, I don't know if I said that, but meter raised to the power 3, it's kuutiometri, and this meter squared is neliömetri in Finnish. And now when we are dividing these figures there by each other, then we see that there are meter times meter times meters cube. Yes, it's the same thing. Thank you. From the chat box, I just, if you are watching only this video, so I just comment from the chat box there. I was told that it could be called also meters cubed as well. But when we divide meters cubed by square meters, we get simple meter, because there you can think that there are meter times meter times meter in the top part and meter times meter in the bottom part, and you may wipe away 1 meters and second meter, so there is left only 1 meter in the top part, and so that means the unit of the coordinate is meter, and it is quite reasonable to think that it is the correct unit for the coordinate. I have here changed the answer to the unit of millimeters. Of course, you could use also meters, but probably in everyday life, probably this millimeters is in measuring is quite common. At least in construction technology, it is very usual. And I think automation technology also, maybe agricultural technology, or there maybe meters are more common unit. And the same holds with the y coordinate there. Only if you have written this in a paper, you may copy that here and just change the values of those coordinates, not anymore x coordinates but y coordinates. If you compare these two calculations, they are same, only exception is that with those parts, those places where you use coordinates. And y coordinate, when we are calculating y coordinate, we use y coordinates there. So this means that the middle point or the center point or the centroid of that figure is place where the x coordinate is about let's use meters, 1.2 meters, and y coordinates is about 1.6 meters. And when we go to the original figure, that means that the center points would be about, was it 1.2, about was that approximately the x coordinate, and the y coordinate was about 0.6. It is somewhere, the cursor of my mouse is now approximately at the place of the centroid of that whole figure. If we could have possibility, and I think it is a good exercise, if you find some hard paper, or what is that? No, not paper. Let's use some metal plate, and you cut that kind of figure from very thin metal, and then you try to hold that figure in balance in your fingertip, and if you try to find the place where that plate stays in balance in your fingertip, that point would be the centroid of that figure. So it is a very nice demonstration. Unfortunately, I don't have. I tried to find something to show you this. Probably I will use this show you this next time. But it is quite easy to demonstrate that this center point or centroid actually is the point where the figure stays balanced in a single point. Yes. There I have the exercise written there. One good way to check if you have learned how to find the centroid point of the figure is to do this not with the same method, but a different method. As I told, it is possible to do this with many ways. This choice which I made in this example, that I divided this figure to sub areas by using vertical lines, as you see here. That is we have other options also, and that exercise there below I suggested to use horizontal lines. So you could calculate this example again by using horizontal lines and dividing it by horizontal lines. Here you would use one line and there another line, and then you get 1, 2, 3 sub areas also. They are totally different sub areas than in this example, and you get totally different intermediate results there. But so actually in this point here, when you are using different sub areas there, all numbers in this figure, all in this calculation here are different. The areas are different, and the center points, well, not necessarily different, but I think in this case they are different, or almost different. But it is strange that even though you have totally different values here, you will get, and also, well, this will be the number in the bottom part of the division. It will be the same, but probably these will not be the same. But some of these sub areas will of course always be the same, because it is the same figure. But even though you have the different values there, the result will be exactly the same. And same holds with the calculating y-coordinate there. And that is one thing which I suggest when you are practicing to some new. I don't know how new this was for you, but if this was new, and always when you are practicing some new methods or some new calculation rules, it would be I would suggest that to do the same problem, or to solve the same problem with a different method, for example using different sub areas. And if you get same result with two different methods, then you probably can believe that you have learned that thing which you are trying to study. And I also have made some other examples there. So this PDF file which I showed you may find from this, from the Moodle, from this study material for geometry, and in the end of that you find this PDF file as I showed you the centroid of the plane figure. And then I have made 3 exercises there for you to practice this thing. I will show you that exercises. And in all exercises there are three figures there. You have to find first the area. It is quite easy thing to do, and but then the coordinates of the centroid in millimeters. I ask you apologize here. I made this in a very hurry today, and after I have actually when I don't know why didn't I see when I was drawing this picture that those figures was not so exactly perfect ones, but I hope you understand that not everything goes goes as you would like it, they would go. I was in a hurry, so these figures are very, very nasty looking, but don't mind about those. And I would like you to practice the end of today's lessons to calculate these exercises, and every exercise do it with 2 different methods. For example, this first exercise, first divide it by, for example, horizontal line to 2 subregions. There is 1 and there is 2, and then you get the answer, and then check your answer by doing it with different method. For example, dividing it by vertical lines by two subregions. You should get exactly the same answer. And then exercise 2 also, and 3 also. And you may use whatever sub-parting you like. You don't necessarily need to use only horizontal lines. You may use in the same problem. You may use both horizontal lines and vertical lines. Whatever you like is the best way to solve that problem. And I think this would be a good place for you to study and practice this method. And I have the correct answers here myself, and I think it would be best for you to start solving these, and whenever you get the result, probably you would like to, and I would like you to write your answer to the chat box, and then I will check if they are correct or not. And also you may check also the others' answers there, so we can all. Previous PDF in chat box. You mean this exercise PDF or that theory PDF? Both, probably. Yeah, okay. I will do that. Wait a minute. I will end the recording here first.